Hello my friends, in this video we will be going over 2008 AIME 2 problem number 8. Here's a view of this problem. We're given a as pi over 2008, and then we would like to find the smallest positive integer n for which this long expression is an integer. Okay, so for that what I have in mind is to first convert this long summation into a telescoping series. So each of the terms here are in multiplication form of some trigonometric functions. So what I will do, I will make use of the product to sum formulas to express each of these in summation form, and hopefully we will get a nice telescoping series as a result. So let me go ahead and write this in summation form. So I will have this whole thing is equal to 2 times the summation sign k equals from 1 to n, and I will have cosine, obviously k square a sine times sine ka, right? And let me remind you that so sine x times cosine y is simply equal to 1/2 of sine the sum x plus y plus sine x minus y. So that should be the formula that will become very handy in our particular case. So therefore I can think of this expression here as an x and this one here as a y. So that whole thing, and thanks to that times 2 here, I can multiply both sides of this here by 2 and I will get the same expression. As a result, this whole thing becomes a summation k equals 1 to n, and so we would have, well, in our case, let's call this one as x and this one as y, I guess, right? So I would have sine the sum first, so I will get k square a plus ka plus the sine of the difference, but the difference with the argument of sine first, so it would be ka minus k square a, and I can close the brackets here. Okay, so organizing this neatly, I should get the summation k equals 1 to n, and here inside I would get sine of k times k plus 1, I assume, right? If I take out the ka, I would get a k plus 1 remaining, so it would be k times k plus 1 a, and then here I would have k. If I take out the ka, I would get 1 minus k remaining, but then I'd prefer to just switch it because each of these coefficients are positive. So therefore I would get, let me do it actually in 2 steps. So I will have sine, so I can take out the ka, right? I take out the ka, I have a 1 minus k remaining here, but then as I mentioned, so 1 minus k will be definitely negative, so I can just switch it, so it will bring the whole sign to negative. So the whole expression here will become minus sine of k times k minus 1 a. So that's what it will become. And now I can expand this summation to make my calculation. So all I do is I start plugging in, starting with k equals 1. I will get sine of 2a, I assume, right? Minus sine of, so that would be just a 0 here, sine of 0. So that's the first, when k is equal to 1, plus when k is equal to 2, I will get 2 times 3, which is 6. So sine 6a minus, and then when I plug in 2 here, I will get 2 times 1, which is 2. So sine 2a. And let me try it one more term so that everyone is confident what's going on. So if I plug in 3 here, 3 times 4 would be 12. So I would get sine 12a minus, and when I plug in 3 here, 3 times 2, 6, so sine of 6a, and I continue in this fashion. So if I go ahead and plug in n minus 1, I will get sine of n minus 1 times n times a, minus sine of, again I plug in n minus 1, so I'll get n minus 1 times n minus 2 times a. So I'll get n minus 1 times n minus 2 times a. And finally, another plus, and now I can plug in n here, so I'll get sine n times n plus 1a, n times n plus 1 of a, minus sine of, and plugging in n again, I'll get n times n minus 1 of a here. And I think I need one more bracket here. Okay, so now we realize that quite a few things cancel out here. So obviously this will cancel with that one, the next one will cancel with that, and so on. So all these will cancel out. So, and obviously this one here will cancel with the previous term's second component, and the same thing here. So this one will cancel with that one here. So all I'm left is these two terms, the minus sine 0 and then the plus sign here. So therefore let me write that down. So I have sine of n times n plus 1 times a, and minus sine 0 is obviously 0. So what I want is to make this an integer, and now it's time to replace the expression for a. I want to make sine of n times n plus 1 times pi over 2008, an integer. And the only way the sine function will become an integer, if you focus on the unit circle, the vertical axis is the sine function. So sine will become an integer only at multiples of pi over 2. So expressing this further, I just realized that sine, if I do the prime factorization of 2008, I realize it would be simply 2 cubed times 251. So therefore this whole thing will become n times n plus 1 times over 2 squared, let's write 251, and then pi over 2. That's it. So as long as I have an integer multiple of pi over 2, I should be in good shape. So we want n times n plus 1 over 2 squared times 251 to be an integer, and we just realize either n or n plus 1 is equal to 251 for us to get the smallest case. But when n is equal to let's say, well, n plus 1 is equal to 251, n would be 250, but then that will not be sufficient to make this whole coefficient here an integer. So what we will need instead is the case when n is equal to 251 actually. So in that case, what we have is 251 times 252, all divided by 2 times 2 times 251. Obviously these two would cancel out, this and this will cancel out, and I will be left with 126. Further canceling, I'll get a 63, and that's exactly what I need. The smallest value, the smallest integer will be there. So therefore the smallest n, positive integer n, which works, is n is equal to 251, and we're done.